Lesson 13.4 is exponential growth and decay. So now we're getting into actual formulas for growth and decay. We're going to have y equals, and then this a value is the initial amount. We've seen that now several times where the first number here is always what the first number is in the sequence, first amount's going to be in the problem. Then we're going to have times 1 plus r. The reason we have 1 plus r is because this is going to be like 1 of itself, like 100% of itself, plus something else. So it's growing more than what it was. So r represents a rate, and it has to be as a, oh, I didn't mean to put percent. They are given as percents. We have to make it a decimal. So the rate has to be as a decimal when you go to plug it in. T is the time. So how long is this going to grow for? Let's try it on number 1. A town has a population of 2,000. So that's the initial amount. It's going to grow, so that tells me I'm using this formula, at 4% every year. What will be the population after 15 years to the nearest whole number? So if I were to make an equation of this, I would have y equals 2,000, because I'm putting it in for the initial amount, times 1 plus, but 4% to change into a decimal, you have to put it over 100, because percents are always out of 100. Well, 4 divided by 100 is going to be 0.04. What it does is it takes wherever the decimal is, in this case it's after the 4, and it's going to move it left 2 spots. Because when you're dividing, you get smaller, and however many zeros you're dividing by in that number, that's how many places it moves the decimal. So 4%, I would just look at this and move the decimal, boom, boom, 0.04. And then we want it to the t power. Well, our time in this problem is going to be for 15 years. So I know that 1 plus 0.04 is 1.04. You could actually just put this whole thing in on your calculator at once, or you could do the 1.04 to the 15 power, which is going to be pretty, not too big. And then we're going to do times 2,000. So get that, or you could have done it all at once, and you get the same thing. So it said to the nearest whole number, that 8 is going to make the 1 round up, so it's 3,602. And that would be the population. All right, now let's talk about exponential decay. Same formula where this is your initial amount. Your r is your rate. Again, has to be as a decimal. And then t is your time. The difference is the subtraction symbol here. So we're going to be less than 100%. Something is smaller than what it started out being. An example of this is when you go to buy a car right off the lot. Its value depreciates. That means it goes down at a rate of 1.75% per year. What will the value of the car be to the nearest cent after 5 years? So I would say the amount of the car, that's my output I'm trying to get, y, equals the initial amount I purchased it for, times 1 minus, well, 1.75 has a decimal right here. I still have to move it 2 places to the left because right now I have a percent. So that becomes a very small decimal because 1.75% was a very small number. It's going to be 0.0175. Do not round, do not change it. And then that's, oh, sorry, not dividing. I'm getting that confused with the compound interest that we do later. And then to the 5th power. And so I've got 1 minus 0.0175 is 0.9825. Again, do not round, keep it all the same. And I'm going to put that all in on my calculator. And it said to the nearest cent. Money has 2 numbers after, so that's going to be 90 cents. So it's $15,105.90, which actually is not a bad price. Didn't go down by too much. All right, and then the last two of these Say, given the following exponential function, identify whether the change represents growth or decay, and determine the percentage rate of increase or decrease. So what I would like to do is actually split this up and rewrite it as 4,200, whatever that was about. That's a starting value of something. 1.603. Since that is greater than 1, that automatically tells me this is growth. Because if it's over like 100%, which is what 1 point something means, that means it's growing. So I'm going to split this up into 1 plus what part is 0.603. That's what this looks like when I did like this right here. So it's like I'm working backwards. So what was the percent or the decimal part of growth would be the 0.603. So if I want to take a decimal and change it into a percent, I multiply by 100, which makes me move the decimal 2 places to the right. I get bigger. So that would be 60.3% growth. All right, and then number 4, I see 0.913. Well, 0.913 is smaller than 1. That tells me it's decay. We're going to be less than what the number originally was because it's less than 100%, which is itself. So if I were to rewrite this, I got to think 1 minus something gave me that. So I could use some algebra here to say 1 minus what gave me 0.913. So to solve, I could subtract 1. So 0.913 minus 1. That gets me a negative, which doesn't make sense. But I see that's a negative what? I'll call it x. Divide by negative 1. So then that makes it positive. So my decimal must have been 0.087. And if I subtract that, I see that I end up back with a 0.913. So somehow I'll work through that. Then if I want to take that and change that into a percent, I'm just going to multiply by 100 or move the decimal 2 places to the right, which is 8.7% decay.